Hey everybody, welcome to this video, you all who are stuck at home today. Here's what we talked about in math. This is the last lesson in Chapter 2. Once we get done with this, we'll be ready for our chapter review and then the test. This is one that is a little bit just kind of weird. It's an advanced topic, but it's not that hard. Your whole life when you've been solving equations, there's only been one answer. So like something like this that's super easy. Obviously the answer, x equals 5. You know, I could do something different and get y equals 12, right? Your whole career, whenever you've solved an equation, here the answer equals 4, there's only been one correct answer. There's been one solution. But in math, what they haven't ever shown you yet is that sometimes you get no correct answer or you get infinite answers. Every single number that you could ever think of would work in that problem. So that's what we're going to look at today. Before I do that, though, I want to make sure I review something. In class today, everyone seemed to think that they did this last year in 7th grade, but just to make sure, did you ever practice the distributive property, something like this, right? You have hopefully seen this before where you can't do the parentheses. I mean, when you do order of operations, parentheses are supposed to come first, but I can't actually add these two because one's a W and one's a 5. And so I'm hoping that last year your teacher showed you that this is being multiplied. That marker is not cooperating. Show you that these are being multiplied, and so then you would do 3 times W. In fact, they may have even drawn those arrows. 3W, and then 3 times 5, which is 15. Hopefully you have seen that concept before, because today's equations are going to involve that type of situation. So if you remember, we did equations last week that had 2 steps or had variables on both sides. Those even had 3 steps. Let me just give you an example here using the thing that I just wrote. All right. I'm going to go ahead and do this, and then I'll do, I don't know, something like this. Right? So here's what's going to happen. You're going to get an equation that has stuff on both sides. This side is not going to be simplified yet. We're going to have to distribute. I can't do the parentheses. And so what I'm going to have to do is do 3 times W. And I'll do 3 times 5, right? Positive 3, positive 5. And I'll end up with this on the left. And then on the right-hand side, this is already as simplified as it's going to get, so I can just copy that down. And you'll get this equation. Now, if you paid attention last week and you were pretty good at how to solve these 2-step equations, I said that we always like to undo the variable on both sides, on the right-hand side first. So instead of plus 3W, I would have had you do minus 3W, right, to cancel it out. And whatever you do on the right, you do on the left. And then here is the situation that we never saw last week. We always had this equal 0. Remember, that was our goal. We get to cross it out because it equals 0. And so we have 15 plus 0, and that's 15. But what we didn't ever have happen last week was, look, this also equals 0. What in the world? How am I supposed to solve it for W if all my W's are gone? How in the world do I solve that? And the answer is, well, you don't really solve it for W since all your W's are gone. That means it's going to be one of these fancy ones at the top. This is either going to be an infinite solution or no solution. And how do you tell which one it is? You just look at the remaining statement. Look at what I'm left with. 15 equals 15. Does 15 equal 15? Of course it does, right? This is the same thing as this. Whenever you get the same thing on both sides, your answer is going to be infinite. This marker is not wanting to cooperate. Infinite solutions. This means any number you think of, you could put it in here for the W, you could work it out, and you would get the same thing on both sides, right? If I put 2 right here, I could have 3 times 2 plus 15. That would equal 6 plus 15. That would be 21. And if I put a 2 right here, I would get 2 plus 5. That's 7. 7 times 3 also equals 21. Or I could pick a 4, or I could pick 7, or I could pick negative 5. Doesn't matter. Any number you pick, it's always going to work. So that is what these equations will look like. Something weird's going to happen, right? You might have even recognized something right here before I crossed all this out. Can you see what I wrote? Do you see how the W has the same coefficient? We have the same amount of W's on both sides. Anytime you see that, you know you're going to have one of these 2 new answers today. So let me do a quick recap here before I move on, because I don't want to make this video too long. How can you tell if it's going to have one solution, infinite solutions, or no solution? Just by looking at it. Today, if you get good at this, you won't even need to work all of these out. So here's what it'll look like if it has one solution. An equation that has one solution will look something like this. I'm just going to split my board into thirds here. Something that has one solution will give you maybe this type of a scenario. Okay? If it has one solution, whenever you get it simplified, you will have different coefficients. Remember, the coefficient is the number that the variable is being multiplied by. If you have a different amount of x's on each side, this is whenever you will get one solution. This is our normal one, where like x equals 2 or x equals 3 or x equals -5, right? That is one solution. That's what one solution means. If you have infinite solutions, like the one we just saw, you end up with a different scenario. When it's infinite solutions, you would have the exact same thing on both sides, and sometimes they'll flip the order. You see how this is the exact same thing? 5 plus 10x is the same thing as 10 plus 5x, right? You have the same amount of variables, positive 5x and positive 5x. Those are exactly the same. And you have the same amount of constants, right? 10 and 10. So not only is the variable part a perfect match, but the constant part is also a perfect match, positive 10 and positive 10. Identical twins, just like the people in 8th grade who are identical twins this year, right? And so then, what is the other scenario? No solution is the other scenario. This is where you might get something like this. Right? No solution. How is this different than what we've seen so far? When you have no solution, the variables will be the same. See this? 5x and 5x. But the constants will be different. See how this is plus 10? I keep using this marker. That's not very good. This one has plus 10, and this one has minus 9. And so this is when you say no solution. Okay? I'm going to review that one more time. This is a good thing for you to pause the video on. Let me actually zoom up here really high so you can see everything. Here is the difference. You just examine the coefficients first, right? If there's different amount of x's, different amount of w's, the variable has a different amount on both sides, the coefficient is different on both sides, you only have one answer. And so today you'll say it has one solution. If the coefficient is the same and the constant is the same, 10 and 10, if everything is a perfect match, you say it has an infinite amount of answers. And then if the variables are the same, but the constants are different, that's when you say no solution. You see how these are very, very similar. They all 5x and 5x, 5x and 5x, but here 10 equals 10, and here 10 and -9. Those are different. Okay, let me give you a couple quick examples. I don't want to make this video too long. I'll maybe just do 1 or 2 more examples and then we'll be done. That board I just showed you is the best one. So, like if we do question number 1 here, I'm going to do, I don't know. And then on the other side, I'll have this. This is maybe going to be the hardest one, right? So on the left-hand side, we have to distribute, right? This is multiplied. 10 times x, which is 10x. This marker is now dying. All of my markers don't want to work today. And then 10 times, this has a minus in front of it, positive 10 times -2. So the left-hand side, I cleaned it up. I got 10x minus 20. Over here, I have 3 terms, 3 things being added. I've got this, I've got this, I've got this. Do you see how these two are both the same? This and this are both x's. Can I add those together, 7x's plus 3x's? Sure you can, that's 10x's. And then the minus 8, I can just drop it down. Now look what we have. Once you get to this point, you always do a little inspection. Are the variables the same? Do you have the same coefficient? Look at this, 10x and 10x. Yes, the coefficients are the same. So I know it's either going to be infinite solutions or no solution. Now, are my constants the same? Is this the same as this? It is not. See how this is -20 and this is -8, or -20 and -8? This is an example of no solution. That's the abbreviation if you don't want to have to write it. No solution. I have the same amount of variables, but my constants are different. That is no solution. Okay, we'll do one more, and then we'll probably be donezo. One that we could maybe do, and then if I do this one, okay, I know I need to distribute over here. 3 times x, that's 3 x's. 3 times negative 6, that has a minus in front of it, but it's kind of like a negative. 3 times negative 6, use your calculator if you're not the most confident, negative 18. And then on the right-hand side, it's all already simplified. There's nothing to do over here. I can just copy down 4x minus 11. Okay, both sides are simplified. I have one variable term, I have one constant term. It's time to inspect it. Look at my inspection here. Are these the same? Do I have the same amount of x's on both sides of the equal sign? No. Whenever you have a different amount of x's on both sides of the equal sign, you have one solution. So this has one solution. Okay, and I'll do one last one. Promise this is the last one. Don't want this to go past 15 minutes. One grand finale question, number 3. So we're going to do, let's see. You know what, I'm even going to put a negative out here just to give you some practice with negatives. Okay, so whenever they give you negatives, don't have a panic situation going on. 3 times x, I can do 3 times x. I keep picking up that blue like it's going to work, and it never does. Negative 3 times x. And then here, negative 3, and this is subtracting. It's like they have the same symbol in front of them, right? Negative, and you can almost treat this like a negative. Negative and negative make positive 18. And look what you have on the other side. 18 minus 3x. Just copy it down. Okay, time to be an inspector here. Let's check it out. I'm inspecting it. Do I have the same amount of x's on both sides? Look at that. I do. Negative 3 and subtracting 3. That's the exact same thing. And then do I have the same amount of constants? Positive 18. This is positive 18. I have identical twins. This is the exact same thing on both sides. So this is infinite solutions. Now I had kids in class. Can I abbreviate that? That's too long. Nope. Can I draw the infinity sign? Nope. I've never seen a real math book do that. Trust me, I would let you if I've seen a math book do that, but I never have. Okay, really quickly, one last time. This is going to be your best friend. Use this board to help you. When do I know one solution? When do I know two solutions, or infinite solutions? When do I know if it's no solution? Different amount of variables, one solution. If the variables are the same and the constants are the same, infinite solutions. If the variables are the same but the constants are different, positive 10 and negative 9, then you say no solution. Okay, guys, I'm going to stop this here. I'm going to post an assignment in Google Classroom. It's going to be a Google slide. You will just have to type in the text box. I have a text box on every single question. There's 12 of them. Sorry, there's the bell to go home. Just type in the text box how many solutions it has. Either tell me one solution, infinite solutions, or no solution. All right, this will be due tomorrow, guys. I'll be posting a review assignment, and then we'll be doing our test a little bit later this week. All right, have a good one, everybody.